Hey everyone, this is Maniac aka the Tinker Dad here, and today I'm not doing the usual quick review video, or to be honest, not doing in the usual style, because what I want to talk about today is this little breadboard. And yeah, this is also from China, also from MacLeod, the usual stuff, but I don't really want to do a review video on a breadboard, but instead using this breadboard I will talk a little bit about how breadboards work, because I've heard a few questions about those, and I just want to show that they are really handy and really easy to work with. So what you can already see here is a working circuit set up on a breadboard. And what does it look like? So this is a Node MCU here, and I just use it to get power from my USB power bank. So as you know, USB gives you 5 volts of power, and I'm just using the Node MCU here. I did it to the breadboard, and I'm getting out 3.3 volts of power from the pins of the Node MCU. So I'm not going into details because you can look these pins up on the pin layout of the Node MCU. So just you can see here there's a red wire here, or is it? Yeah, it is red. Okay, not the best lighting, to be honest. And this gray wire here. So at this point, this is the negative, and this is the positive pin out, or in other words, this is the VCC and this is the ground. So how does the breadboard work in this case? You can see colored lines here, this red one and the blue one. Basically they are lanes. Those mean that these holes next to the blue line and these holes next to the red line are connected under the plastic of the breadboard. So basically whatever you put or connect to those pins will be connected to the adjacent pins, so the pins next to it. Means that in this case I connected the VCC to this pin and to this hole. That means that whatever I connect to those pins next to it along the red line will also have the same voltage, and this is what exactly happens here. So I connected a resistor here, you can see. Okay, so let's see the other side. So this is the ground pin, or one of the ground pins of the Node MCU, and I use it with this brown wire, or this gray, more like gray wire, to connect it to another lane marked with the blue color. And this means that all these holes next to the blue line will be connected to the ground of the Node MCU. So these are the power lanes basically. The ground for blue, the red for the actual power, so for the VCC. You can see here that there's a break in the lines here, and that means that these holes are no longer connected there. So it's a separate power lane. I could set up a similar circuit on this half of the breadboard and have it totally separated from the other half of the breadboard. So basically a breadboard like this gives you 4 power lanes, complete with both ground and VCC. Okay, so what about the rest of the board? You can see letters here, and you can see numbers here. So this is like a matrix. You can give an address, or this is just for you to remember stuff or to document stuff, but you can name or address these holes together, like saying this is A0 and let's say this is B5 and so on. The point is that each of these columns are connected together from A to E and then from F to J. So for example, whatever I connect to, let's say F0 or sorry, F3 here, it means that it will be also connected to G3, H3, I3 and J3. Also the same with A to E. So you can see how I set up this LED. So I connected the pin of the resistor here, and in the same column I connected the pin of the LED. So these are basically connected together under the plastic surface of the breadboard. And this is how this whole thing becomes a circuit. So from the node MCU, you can see here's a node MCU, and under the node MCU its pin is connected to the column here, and this is just basically in the same column with the 3.3 volt out pin. Next is that this is connected to this power lane, and because this whole power lane is connected together, the voltage comes and enters the resistor. The resistor goes straight here, which is in the same column, and the other part or other pin of the LED goes to this ground lane, which is connected to this wire, and in turn that wire is connected to the same column where the node MCU's ground pin is connected. So in very high overview, this is how a breadboard works. And that's the main point of having a breadboard. You can experiment. You don't need to solder anything. And basically with all these columns, these numbers, these letters, these colored lines and the separate power lanes, basically it just guides your hand to have your experiments done as easily as they could be. Okay, so much about breadboards. I really can't tell too much about it. They are quite simple and quite handy, as I said. If you want to tinker with electronics, you will definitely need one, at least in the beginning. Okay guys, so thanks for watching this, and see you next time. Of course, if you like this video, hit the subscribe button. Thank you in advance.